Yesterday we multiplied, today we are dividing. Remind me how we multiplied yesterday was the first thing that we checked. Index. What about it? Had to be the same. Good news. Same rule applies. To divide, again, the index must be the same. Come on, Kate.
We're doing notes already?
Dog.
You're moving fast.
Yeah, mine exploded. Who knows? Okay. Just like yesterday, when we multiplied, what did we do with our radicand, our inside number? When we multiplied? Like if I had square root of 3 times square root of 5, what did we do with 3 and 5? Multiply. Guess what we're gonna do today? Divide in your calculator. Oh, hold on, pause. First check. Index the same?
Yes.
Yeah, okay, divide 2, 16, and 6. 36. So I have the square root of 36. It's wavy, I'm scared. What is the square root of 36? Plus or minus 6.
No, oranges. It's a flamingo.
Jonah, you got notes?
Hey, Dennis,
What?
can you buy me a flamingo?
No. Also, I feel like we're not surviving North Dakota winter.
You will. I'm surprised. Just,
How much would a flamingo? How much would a flamingo cost?
I have to
No, I
stuff
want
it.
a flamingo.
Stop it, jeez. Alright, B, are my index the same? Yeah. So what do I do with 50 and 2?
25.
I get 25. Yesterday.
You subtract the
Subtract.
Ooh, when I had x squared and x cubed, that became x5 because we add. Bless you. When we divide, we subtract. So I got how much x? X2 under the square root.
Then you get minus.
Then I get 5x. The square root of 25 is 5.
Plus and minus or
Not really.
no? Okay.
And then the square root of x squared is x.
Is that plus or minus or what?
Not necessarily. Because if you had to do that for each one, I'd feel really bad.
Plus or minus?
Yeah. Pretty much when it says simplify, you don't really have to worry about it. But when it says like what are the real roots, then we gotta do our plus minus. Blake!
Hi.
Friday.
That's what we were talking about.
I know it was.
Friday.
Okay. C. What's the first thing I have to check? Indexes are the same? Yeah. So I'm gonna do the cubed root of what? 27. And I get x how much? X5. Okay. Is 27 okay to go with the cubed root?
Yes.
Yes. Is x to the 5th okay to go with cubed root? No, I gotta break it down to what?
3.
X3, X2. You said I can bring out 27 if I bring it out, what is it? 3. My x cubed can come out and become x, and what do I gotta do with my x squared? Leave it in my cubed root.
I know. Not as much.
Okay. Are we good on C? Okay. Stick with me, D's a little bit more complicated. Ugh. Okay, first things first, index, we okay? Yeah. 243 and 3. 81. What about my x's? X squared. Okay, what's wrong with my y's?
The bigger one's on the bottom.
The bigger one's on the bottom. Okay, so what we're gonna do is leave it on the bottom. Okay, we have the cubed root. What happens with my y on top and y4?
Y3 on the bottom.
Y3 on the bottom. How do we know, Courtney?
You can give little ones.
So if you subtract again, like except for we know it's gonna be on the bottom, so opposite. 4 minus 1 is 3. Or, now remember, do you guys work with negative exponents?
Yes.
Yeah. Negatives are always on the bottom, so if you do 1 minus 4, you get a negative 3, so that's just a 3 exponent on the bottom. Okay? Whenever you have a negative, so like you see how this is a y1, 1 minus 4 is negative 3, that's the same as just a positive 3 on the bottom of your fraction, in the denominator. Okay? Questions here?
Is that our answer?
No, we gotta simplify. What can I do with 81?
27 and 3.
27 and 3. So I'm gonna break this down. So here's like a new step. Cubed root of 27 and 3. Can I do anything with x squared? Nope. And then on the bottom, I can just take out my y. Okay. Last step, I can deal with 27, right? If I pull it out, what does it become?
3 and 3.
So I got 3 cubed root of 3. Can't do anything with my x squared, so leave it over y, and this is our answer. It is gross. If you want to go straight from the 81 to this, that's fine with me.
That is a lot.
So many 3s.
Mm-hmm.
Like if you want to skip this step. Okay. On the last, we got 3 more. We're gonna do more of the rationalizing your denominator. Okay. What rationalizing means is just like when we had 1 over the square root of 3. Did we want square roots on the bottom? No. So what did we do? Times by square root of 3 over square root of 3 to get rid of the square root of 3 on the bottom, right? So this became square root of 3 over 3. Okay, this stuff is called rationalizing the denominator. And that's what we're going to do in these. It's just not as pretty. Okay? Alright, starting with A. Can I, first off, index the same?
Yeah.
Yeah. Can I deal with 11 and 12? No, it's not nice, so we're just going to leave them. Can I deal with my x's?
Yeah.
Yeah. Okay, so let's make our top 11, our bottom is 12. What am I going to do with my x's? Subtract them,
X on the bottom.
and I have an x on the bottom. How do I know it's bottom? Bigger numbers on the bottom. 3 minus 4, negative 1. So how much x on the bottom? 1, because 4 is 1 bigger than 3. Okay. What happens with my y's?
Yes, no.
They cancel. Okay. So just like y divided by y is 1, the square root of y divided by the square root of y is 1. Okay. So we're not worried about them. Okay. Good through there? Okay. Can I break 12 down at all to help out? To what? 4 and 3, okay? So I guess I didn't need such long stuff. Square root of 11 over square root of 4 times 3x. And what can I do with the 4?
Take it out.
Take it out. Okay, so I'm just going to go down here. So I have square root of 11 over, when I take it out, it becomes what?
2.
2. And then I still have square root of 3x. Okay. Good through there. Do I have a square root on the bottom?
Yes.
Yeah, I don't want it there. So, what guesses on what we multiply by?
3x.
Square root of 3x. Good. So just like here, we multiplied by what's on the bottom. we're gonna multiply by everything under the square root, okay? And just like here, we're gonna multiply both top and bottom. So top and bottom by the whole square root of 3x. Okay? So everything that's under our square root. Now we're multiplying like we did yesterday. What is square root of 11 times square root of 3x? Square root of 33 x. Okay, here's tricky stuff. Square root of 3 times square root of 3 became 3. So what's the square root of 3x times the square root of 3x? 3x. Pretty much all you're doing is getting rid of your square root sign. Okay. Can I do anything with square root of 33x? No perfect squares, right? 11 and 3, nada. So we're going to have on top square root of 33x. On bottom, I can combine 2 times 3. And finally, we have reached the end of our adventure. Yuck. If you think about it, the only bad part was the rationalizing. It was all bad. It was all horrible. Okay. B, do I have indexes that are the same? Yeah. So I can divide. Can I do anything with 7 and 5? No. Okay. So we're gonna write 7.
You just need to erase the other stuff.
I erased the
That's
square
what
root of
the red.
three. See
You
that?
should just erase the red stuff so you don't remember.
Well, I was just gonna write down the same, okay? You got lots of them down, don't you?
I'll just leave it.
My x's. Can I do anything with it? Not x's, just x. Nope. What about my y that's my denominator? Can I do anything with it? Nope. Can't bring it out, can't do anything. Okay. Well, what could I make my bottom so that stuff could come out? Like, how much more y do I need in order for y to come out?
1.
I need 1y. What about in order for my 5 to come out? What would I have to multiply by in order to get my 5 to come out? Say what? Feel like Caleb, you had an idea?
5.
5. 5 times 5 would be 5 squared. What about,
Ugh.
I want 5 to the third, right?
50.
25.
25, because 5 times 25 gives me 125, which is a perfect cube. Okay, so we're going to multiply. Here, we'll go, I want, on my bottom, I want 5 to the third power, so that I can take a 5 out. And I want y to the third power, so I can take a y out. True or false?
True.
True. Okay. And so what I'm going to multiply by, I don't want to multiply by all this, because I have some of it. How much more 5 do I need? 2. Yeah, I need 5 squared in order to make 5 to the third, right? How much more y do I need?
1.
1. So I don't want to multiply by this whole thing. I just want to multiply by the parts that I'm missing. Okay? What do I multiply by on top?
7 squared and x squared.
Do I care if the top is rationalized? No. When I had square root of 3, what did I multiply by? Same thing. So I need to multiply the top by the exact same thing I multiply the bottom by. Okay? Y1 or y. Okay, like I said, I don't care about the top. Okay, I don't care if anything can get pulled out. I just care about the bottom.
Is that why?
Y1. And I was trying to scroll down, but then I made a mark, and so it started confusing everyone. I could have won. That's probably still confusing. Okay. So let's multiply our top. I have a third root of my number part is what?
175.
How do we know? Multiply. This is 5 squared. So I'm taking 25 times 7, which you said is 175. Okay. Can I do anything with my x? Nope. Can I do anything with my y? Nope. Okay, questions on top? Okay. On bottom, I now have my 5 squared times 5, which is 5 cubed, right? And I have y what? Y to the third. Which means on my bottom I can do what?
It's just 5y.
It's just 5y. Okay? So I'm going to write my whole top. We said we can't do anything with it. 175 xy. And my bottom is going to become 5y. I don't care that my top is nasty. I just care that my root, my radical, is out of the bottom.
So you don't have to pull 25 out of 175?
No, because it's a cubed root. If it was
Oh,
a
that's right.
squared root, yeah. Check your stuff, but I don't think anything works with the cubed root. Okay. So just remember, whatever you multiply to make your bottom nice, have to multiply your top by. Yeah, but
I feel like this is just manipulating the problem into a different problem so you can solve it.
Yeah,
Like, it's
so it just kind of makes the bottom nice.
just stupid.
Just stupid. Okay, that's just like your go-to. Okay. C, are my indexes the same? Yep. Can I divide? Yep. Can I simplify 8 and 32? 1/4. You guys agree?
Uh,
8 divided by 32 is 1/4.
Yeah.
Yeah.
Why you question?
We got a dead crowd today. Can I do anything with my x's?
No.
No. Could I break it down?
Yes.
Okay, what should I break it down into?
Yes.
X to the third and x, okay? Why did we do this? Why did we break it down? Why didn't we just leave x to the fourth?
Because it's to the third.
Yep. I can eventually take it out in my next step, okay? Can I do anything with my y squared? No. Is there any point in breaking it down? No, because I'm not going to be able to pull it out because 2 is less than 3. So I'm going to leave my y squared.
Same with
Z is already to the third. I don't want to break it down because I got a third here. I don't have a Z on top or anything. So I'm just going to leave it. Okay. First thing I like to do is pull stuff out. It's kind of like when you're factoring and we pulled out greatest common factors. I like to pull stuff out before I rationalize, because if you don't, you might be multiplying by too much. Okay, so in the top, my 1 doesn't really matter. I just wrote it there for good conscience. Everybody. My x cubed, what can I do with it? Take it out. So I have x, and what am I left with? Cubed root of x. Okay, top's all good to go. On my bottom, can I do anything with 4? Nope, so that's going to have to stay in. What about y squared?
No.
Stays. What about z cubed?
Yes.
Yes, I can pull it out because I got a cubed. So I got z, and then everything else stays in. my cubed root.
Is that your answer?
Oh, yes.
Why is it not my answer?
Can't have
Bottom.
that.
Okay. You can do a couple different things. We are going to try to make this as simple as possible. So, whenever you have numbers that can be broken down into perfect squares, perfect cubes, you always want to try to break them down. Can I write 4 as a power of 3? No. Can I write 4 as a power of 2? What can I write it as? 2 squared, yeah. Okay, so I'm gonna write, instead of my 4, I'm actually gonna erase it. And I'm gonna write 2 squared. And then we had our y squared, okay? So this 2 squared is the same as 4. Have I changed any numbers?
Yes.
Well, yes.
I didn't change it, it's still
We
4.
changed the 4 to 2 squared.
The value is the same.
And you changed the numbers.
It just
So
looks
you changed the numbers. So you changed the numbers.
Yeah, I agree with
The
Kate.
value is the same.
But you said,
Okay, I
Then
changed
you
numbers,
asked that,
but the
yes,
value
you
is the
changed
same.
numbers.
Okay. Whatever, technical.
Mm-hmm.
Okay. The reason
Supposed to be.
we change it is because now instead of multiplying by 4 squared to complete my cubes, I now only have to multiply by what? 2. Okay. So to get rid of my bottom stuff, Courtney says I now only have to multiply by 2 to get a cubed. What about my y? What do I gotta multiply to complete that? Just y. What am I multiplying my top by? Same. Cubed root of 2y.
Where did the square
Say
go?
what?
It's gone.
Here? Because I don't want a squared because that would make this 4 and I can't take 4 out if I have a cubed root.
So you just carried on then, or what? Does it just disappear? the
Well, it's a
square?
1 because 2 plus 1 is 3. And that'll.
This is just making it so much more difficult.
So much more. Did you think we were going to stay on multiplying and easy stuff?
But
forever?
like, I don't understand where the squares go.
Well, the squared's right here and right here.
I
Okay.
thought we're
But when
trying to get rid of it.
Right, and the way that's we're gonna get rid of it is because 2 times 2 squared is 2 cubed, and that's gonna get rid of it. You want your exponents to match your index.
Well, then why did you have to put 2 squared? Because 2 times 4 is 8. And that,
But you want 2 to the.
And the cubed root of 8 is
yeah.
2.
Well, then you didn't have to put it in 2 squared, did you? You could
use
have just
it.
left it as 4, and then 4 times 2 is 8, and then find the cubed root of 8.
Just keep going.
So if you would have left it in 4, you would have multiplied by 4 squared. So that your 4 is a root.
Okay, all those questions just made this a lot more difficult.
You want your exponents to be the same. Okay, so let's, multiplying our top. I have x outside. Inside my cubed root, I have what? 2xy. Nothing changes. I don't combine anything. I have all separate stuff. Okay, let's try writing our outside like this, or our bottom denominator. The only thing outside my bottom, my denominator, is z. Okay, then if I combine my inside of cubed root, I have 2 squared times 2,
Okay.
which is 2 cubed. Y squared times y is y cubed. Okay? 3, 3, 3. It's like a green light. Go. Leave your top. X to the third root of 2xy. On the bottom, I have my z outside. What else can I pull out now? 2 and y. I like 2's out front. So 2, ZY, YZ, doesn't matter.
Was canceled. Or no, 'cause it's on the-
No, because on the. Okay, so the reason we multiply by 2 is so that our index and our exponents match, so that they cancel out, so that I can bring them up. Okay, questions?